Welcome back, focused learners. I've got some bright, kawaii energy for you today because we are exploring something truly fascinating. If you've ever looked at a beautifully crafted, multicolored 3D printed creature and wondered, how on earth does a massive farm produce this with flawless efficiency? Well, you're in exactly the right place. In this explainer, we're going on a journey to master 3D printing logistics. We're bringing that fun, creative energy right into the highly structured world of production. By the end of this, you are going to know how to think exactly like a PCP production technician.
Okay, let's dive into this and lay out our highly structured roadmap for today. We're going to build this skill set piece by piece. First up is the production mindset, followed by a look at the printer fleet. Then we'll get into purpose-driven materials, uncover the eyes first principle, and finally, we'll tie it all together with the decision pipeline. Section 1, the production mindset. Let's start thinking like a pro. It's so tempting, isn't it, to blindly assume that the absolute fastest print speed or the shiniest new hardware is always the best choice for a job. But in reality, that can totally bottleneck your entire operation. Your job as a tech isn't merely to make a single model printable. You have to think strategically. You're optimizing the output of the entire farm. It's like a giant puzzle where you're constantly weighing print time against waste, labor, failure risk, and the final value to the customer. Sometimes the absolute most efficient choice for the farm is actually putting a job on a slightly slower machine. Why? Just to keep your high-capacity multicolor printers totally free for the jobs that literally demand them. Section 2, the printer fleet, and what we call our specialist metaphor. Now that our mindset is locked in, let's talk hardware. On this farm, every single machine is a highly specialized crew member with its own distinct strengths. And this brilliantly illustrates how you map the right tool to the job. The Centauri Carbon, the CC, is your powerhouse for high-volume, single-color work. Think large, blocky models. The A1, that's your dependable, everyday workhorse, perfect for standard minis. But when you step up to complex, articulated multicolor dragons or flexible TPU, the U1 takes the stage. And for those massive, premium, high-color display pieces, we call in the H2C. Every specialist has a role. Let's look a bit closer at those multicolor heavy hitters, because there are some very real trade-offs here. The U1 uses a snap swap system. It physically exchanges up to 4 tool heads. This massively reduces purge waste, making it our absolute favorite for articulated dragons using 4 colors or fewer. The H2C, on the other hand, uses a Vortec hot end change system that can hold up to 7 materials. 7! It's completely unmatched for complex premium batches, but it does require more setup overhead. So you're always matching the color count and waste benchmarks to the right machine. But color isn't the whole story. Geometry dictates our hardware choices just as much. Think about a tall, skinny model. Vertical height naturally amplifies motion and wobble. You absolutely need the stable frame of a Core XY machine, like the CC, P1S, or H2C, to prevent a mid-print disaster. You definitely don't want that thing tipping over. Conversely, large blocky models are right at home on the Centauri Carbon, while large round models tend to thrive on the H2C or P1S. The geometry always points you to the correct motion system. Section 3, purpose-driven materials. Time to pivot from hardware to the artistry of filament selection. The finish you choose completely changes the product's identity. We tier these materials by purpose, economy, standard, and premium to protect the price ladder and add visible value for the customer. Printing a soft pastel character or a realistic animal? Go with a matte finish. It softens the layer lines and removes those distracting reflections. But a fantasy dragon? Oh, you want silk for sure. It gives it incredible shine and movement. Just remember the golden rule. When using silk, you must drop that outer wall speed down to 60 millimeters per second to preserve that premium shine. And gradient filaments? Only use them on models large enough to actually showcase the dramatic color transition. Section 4. The eyes first principle. Let's intentionally slow things down a bit here. We've talked a lot about rapid-fire production metrics, hardware specs, speeds, and feeds, but I want you to take a second and think about this. What actually turns a printed plastic object into a creature a customer loves? In a market where literally everyone is competing on size or how many articulating joints a model has, how do we create genuine emotional attachment? So, the crucial point is the PCC eyes first principle. Customers naturally look at the face first. The eyes create personality. They make a creature feel shy, excited, magical, or playful.
Making the face feel alive with clear, cute eyes adds infinitely more perceived value than just splashing expensive, random colors all over the body. The eyes are never an afterthought. They are our primary focal point for value.
And here is one of our absolute favorite secrets for achieving that magic: Dape Galaxy Black Filament. It has this very subtle sparkle that catches the light, giving the eyes a glossy, lifelike depth that a flat black literally just can't match. It immediately cranks up the cuteness factor. But as technicians, we don't just use it blindly. If you have a design that's meant to be spooky or hyper-realistic, a sparkly eye might totally ruin the vibe. In that case, flat matte would be way better. It's all about intentional emphasis. Section 5. The Decision Pipeline. Let's bring all the hardware, materials, and aesthetics together. These are the strict PCC slicing standards you need to internalize. First, 3 walls or wall loops. Why? Because 3 walls add structural strength far better than just packing the model with heavy infill. Speaking of infill, 10% gyroid is our baseline because it supports the part in multiple directions. For regular PLA, our speed sits at 150 millimeters per second. But pay close attention to that first layer, 30 millimeters per second. We use a delicate, slow speed there so tiny claws and intricate contact points don't just get whipped right off the bed by rapid direction changes. Oh, and no Brin preferred, if we can avoid it.
Now, prints will fail. It happens to everyone. But when they do, you cannot frantically change 5 settings at once. You have to maintain a calm, logical approach. Identify the likely cause. Is it bed adhesion, cooling, a mechanical issue? Then make exactly one controlled change. Just one. And document the result. If you change multiple variables at once, you will never truly know what fixed the problem, and your production file will become an unreliable mess.
Let's move to and see how this builds into the ultimate decision flow every technician must follow when a new design crosses their desk. Step 1. Understand the product geometry. Is it tall, blocky, articulated? Step 2. Choose the right printer tech and material tier for the job. Step 3. Protect the eyes and face. Apply that eyes first principle so it feels alive. And finally, step 4. Apply our slicing standards, run a test, and review it.
All of this brings us right to our core mantra, the absolute foundation of our production pipeline. Every printer is a specialist. Every material should have a purpose. Every face should feel alive. It's not just about making plastic printable. It's about making every single choice intentional. So what does this all mean for you? Well, now that you have these expert strategies at your fingertips, what magical creature are you going to bring to life first? Thanks for joining me on this explainer, and happy slicing.